Let me okay. Okay. So I want to just review things that we were talking about. We started this Thursday, worked on it Friday. We're going to finish it up today. You will have homework. So just to review things that we're talking about, you do not need to write these down. So let's say we have this. I'll zoom in a little bit so you can see it. Just to review, exponential or linear? Exponential, linear, or we could go neither. Exponential, linear, neither. Okay, that's the first thing that we talked about. Should be in your notes. If you cannot remember what it means for something to be exponential, then you should get your notes out because that's the way we're going to do this. What is linear, exponential, or neither? I think it's exponential. Okay, the definition of exponential is that it does what? It multiplies by the same number every time. What number do we multiply by here? 2. If we can go, hey, we multiplied by 2 every time, this is exponential. Okay, folks, so that should be in your notes. Okay, linear, exponential, or neither? Exponential. Also exponential. What do we multiply by? 0.5. Yes, we're multiplied by 0.5. So we're multiplied by 0.5. This is exponential. Just a 90. Doesn't look very good, but it's a 90. Linear, exponential, neither. This is linear. Why is it linear? We subtract 10 every time. So we talked about this, that if you add or subtract the same amount every time, this is linear. If you multiply by the same amount every time, it's exponential.
No, she's literally crying paper. I can hear it.
He's not doing it, he's just sitting there. They're wasting time. Still not learning all. All right.
Just pull it, Elijah.
I can put it on her desk.
It's not, is it? Okay. You guys, please fix it. Okay. You are 3 weeks away from being sophomores. Right? 3 weeks away from being sophomores, so we should not be acting like middle schoolers. Okay? That's where we're at. Linear, exponential, or neither? What do we multiply by every time, Charlie? If you can't figure it out, it's probably not exponential.
It's neither.
If you're going to multiply, what do you multiply by for this first one?
2.
You multiply by 2, and if you multiply by 2 again, what should you get?
4.
Do you have 4?
No.
Then it's not exponential. If it's going to be linear, what are you doing? You're adding 1, and if you're adding 1, what would the next number be?
3.
It's not that either. So this is neither. Okay, linear, exponential, or neither. I'm not doing any more of those because that is stuff that we talked about for 2 days. So we talked about this. We We talked about like if you, yep, you're right. If you have an exponential function, we talked about function notation. I would like you to please find f of 2 for me. Okay, find f of 2. Okay, what's f of 2?
32.
32. What do we do when we see that f of 2? What does that want us to do?
Plug it in.
You put the 2 where the x is, and you guys just put it in your calculator. So this means this is 2 times 4 to the 2 power, this 2 because this 2. Okay, put in your calculator, that's 32. Okay, how about f of 1/2? Yeah, I don't know. I don't know where 24 came from. How about 32? Whew. Okay, how about f of 1/2, please? F of
Do you
1/2.
want it to put, can we do 0.5 or more?
You can put it in 0.5 in your calculator. Your calculator's happy to do decimals. What do you get?
1.549.
I got 4.
You didn't put it in right.
Oh, that's a time.
It's not a decimal either. Yes, it's times. 2 times 4 to the 1/2.
I thought it was 2 minus 4 this whole time.
No, that's times. Okay. Now, I would like you in your calculator, please, to graph y equals. Let's do 2 to the x plus 1. 2 to the x plus 1. Okay, put it in your calculator. Yeah. Okay, and go ahead and graph it. And then I want you to put a sketch on your paper. Okay, so we're back to taking notes, and this was pretty abysmal when we started when we did this on our warm-up. So obviously we got to do some more notes. So, okay, I want you to put a sketch on your paper. It does not have to be perfect, but it needs to be decent. Say again.
Why would you get about
I don't know what you're talking about. Sorry. What are you talking about? Because that's what your graph looks like. There you go. Make more sense now?
Yeah.
Yeah. Okay, if you're if your graph, okay, listen, folks, if I'm answering somebody's question, you can be quiet because I don't want to have to take 30 seconds every time to get your attention again. Okay, it's going to be that if I have to, I'm keeping you after class and not writing you tardy passes. Okay, like the whole class. So I'll just start counting my seconds and you'll stay. If it doesn't look like that, zoom 6. Okay? If it does not look like this, so that's what's Gabe's question. He's like, I don't see all of that. Right. If you don't see that, zoom 6, and then you'll be able to see what the graph actually looks like. So 4 important things that we care about. Okay? The first one is its domain. Now, I said on the warm-up, and I'm only going to say it one more time. This is freebie points. The domain of an exponential function is always all real numbers. You may write any number. You may write out in words all real numbers, or you can put the little r with the double backbone. That's what that means. It means all real numbers. It's really like 2 lines and then draw the big R. Okay. Now, range is your y values. This will always be an inequality of some sort. Okay? I guess that's not true. You can put it in words. But if you're going to not write it in words, it's going to be an inequality. So look at this graph. This guy levels out to the left. What's that lowest it's going? It's 1. It's 1. Now, are the numbers above 1 or below 1? They're above. Those numbers are above 1 on the y-axis. So you can put numbers above 1 like that, or you can write y is greater than 1. Now, I said this on the warm-up, but this number is this number. So you don't have to guess. Like somebody asked me that and I wasn't answering the question yet. Somebody was like, how do I know what it is? You can look at the equation and know what the asymptote is. Okay. Oh, and what the range is. So we're going to write the equation for the horizontal asymptote, HA, horizontal asymptote. Okay. Horizontal asymptote is the line that this guy is running along as he goes out either left or right, depending on our equation. Okay. What is it? Y equals what? 1. No guessing. It's the same number that you use here because it's the cutoff point. If it's not going to go below that, if it's numbers above that, then that's the asymptote. That's just how an asymptote works. Okay. And the last one is the y-intercept. And I said to you, it's always a coordinate point with 0 for x. So you come up to your equation and you plug 0 in for x. You do 2 to the 0 plus 1. And if you need to use your calculator, use your calculator. But you could use your brain too, because you know that anything to the 0 power is what? 1. So 1 plus 1 is 2. And you're done. But if not, literally put in your calculator, do 2 to the 0 plus 1. And it will also tell you that it's 2. There you go. Okay, so we're going to do 2 or 3 more depending on how these first 2 go. So I would like you to graph, now we're going to do 3 because I can make it a little bit different here. So let's say we're going to go 10 to the 0.75x plus 3. 10 to the 0.75x plus 3. Pop that in your calculator. Okay, and you can put this, it's 10 times 0.75. Sorry, I said that funny. 0.75, and you put it exactly with the parentheses like that. Listen, just make sure that your plus 3 does not go up in the exponent. Otherwise, you're going to have a very different graph than the rest of us.
Is the exponent of the outside of the parentheses?
Mm-hmm. Okay, so you should see a little bit of it there. If we need to zoom out, do zoom number 3 and hit enter once. I wouldn't go much beyond that because it zooms out quite far and that's not super helpful. Okay, zoom 6. If you zoom 6, you just get the little corner of the graph here, like that. So, it looks like this. Okay, now, what's his domain? All real numbers, because it always is. You guys, that's free points on the test. Not 3, free with an F, free points. Okay, like you should write that down when you have a test question. It's not going to, cannot be anything other than that. Now, the range, it's a little bit hard to see on this one because of the graph's a little bit off the graph a little bit. But I talked to you about the fact that you don't have to guess. What's the range?
3.
Above 3. Numbers above 3. And we know that. We're not guessing. We know that because of the 3 in the equation. Okay, so if I write it with an inequality, it's y what? Y is greater than 3. Okay, the equation for the horizontal asymptote always is y equals, what's it going to be? 3. Because it's the same as the range. It's the same number that we use there. Okay, y-intercept has to be 0 something. 0, 13. Then you're not even seeing that on your graph. So if you don't want to exponent rule that, put in your calculator. 0.75 to the 0 plus 3. The way that it works out is it takes this first, exponents first, so it turns that into a 1. So it's 10 times 1 plus 3. That's where 13 comes from.
Wait, I have a question. Will it always be 0, like the front, because
Yes, because that's the definition of y-intercept. The y-intercept happens when the x equals 0. Okay, let's try this one. Let's go, so you can clear out your calculator. Let's do y equals 3 times 2 to the x power. Okay, 3 points. What's the domain? All real numbers. Now, we're doing this one because some people, not everybody, some people are going to be frustrated because you're like, I don't even know. What's that number? Okay, you told me it was the number, Mrs. Douglas. I did. What's the range? Numbers that are above what?
3,
Nope.
2,
Nope.
0.
Yeah, because look, these are the thing that's added to it, right? Added to it up here. What's added to this? Nothing. So it's 0. And you can look at your graph though and go, hey, that's what it's looking at. It's running along that 0 line. Okay, numbers above 0. If you write that as an inequality, what do you get? Y is what? Greater than 0. Horizontal asymptote would be y equals 0. Same number here. 0. Okay. Y-intercept, coordinate point, plug in the 0. There's your 3. Okay, now 2 more. Let's go y equals -4 to the x plus 3. -4 to the x plus 3. Make sure your plus 3 is not in the exponent. That does something different. Okay, got a different looking graph this time. Which is why we're doing this one and one more, because we'll switch it up a little bit. Okay, what's our domain? Right, because that is always true no matter what the shape of the exponential graph is. Okay, now, being a little bit tricky here. Okay, only a little bit tricky. Liam, what do you think?
You want me to answer the range?
Yeah.
Y equals 3. It's above.
Well, it's not equals.
Y is less than.
Y is below 3, right? If this is 3 here, which it is, correctly identified as 3, are these numbers my graph above that or below that? Below. So this is numbers below 3. And if we're going to write it as an inequality, it would be y is what?
Less than 3.
Less than 3.
Can we just write it as like an inequality?
Yep. Absolutely. This is a either or. Yeah. Do you want to use the bathroom? Okay. So horizontal asymptote.
3.
So equation.
Y.
There you go. Make sure that when you write horizontal asymptote, it's an equation. Okay. Now y-intercept. 0, 2. So 0, 2. Okay. Now, last one. So let's do y equals -2 to the x minus 3. Okay, what's the domain? All real numbers, you guys. Always, always, always. What's the range?
Y is less than 0.
Nope.
Y is less
-3. Right? Because here's our line right here. Okay, this number, y is less than -3. If you want to write it in words, it would be numbers below -3. It's below. One more time. It's below because the graph is underneath that line. Like, don't overcomplicate the fact that it's below -3. Okay, it's below as opposed to above. Wait just a minute. We're almost done. Okay. What's the equation of the horizontal asymptote? Y equals what? -3. Right? Because this number.
But it's not.
It can subtract too.
Oh.
It can subtract also. So adding or subtracting doesn't matter there. Okay. And then the last one, the y-intercept, is going to be a coordinate point. So 0, what?
Negative.
Yeah. How to think about that one. 0, -4. Okay. I'm going to show you one thing on your calculator that's handy. If you do, this is just a little cheater thing that I'm happy to tell you. If you hit trace, so up here is trace, next to graph and zoom, right in the middle, trace. If you hit trace, it usually will come on to the y-intercept, assuming that you've hit zoom 6. Okay, do you see that it comes up 0, -4? If it wasn't there, you can literally just hit 0 and hit enter, and it will take you to the y-intercept, so you don't have to type it in again. So then you don't have to guess, you don't have to count the dots, it's just right there. So trace, 0, enter will give you the y-intercept. Okay, that's a handy little cheat code built into your calculator. Okay, so let me give you your homework assignment. I would like you to, while I'm writing this down, I would like you to understand that we have a quiz on Friday that will cover this material and our exponent rules. I'll get some just a second. Okay, so right here on number 19 and 23, 19 and 23, you're doing what we were just doing. So you're not following the instructions in the book. Okay, you're graphing it, you're finding domain, range, horizontal asymptote, and y-intercept. Pretty close to the same thing that's in your book, actually. It's just that I also added the y-intercept. But you're doing all four of those things just like we did in class. Abby, you may go now. See, Gold Star Club, I want you to do... Nine and 10. 12, 15, 19, 23, 38, 62. There you go. Yes. Of course. Yes, you may.